Welcome to Braille Institute. Now discussing the maximum likelihood estimation. So in last class we discussed the method of moments, how to find out the method of moments. So we have a population. So population have the large samples, large number of datas. So this population have the number of data. This population is following the one distribution with the unknown parameters. For example, this population is following the exponential distribution with the unknown parameter like that. So we'll write it like that: exponential distribution, and unknown parameter is lambda. So we have a lambda, we don't know the value of lambda. We know mean of the exponential distribution is equal to 1 by lambda. So from this population we are going to select one sample. So we have a sample size we are taking the n size is equal to n size of samples. Some sample is taking from the population. So samples are S1, S2, S3, S4, S5 and up to Sn. We have taken some samples from the population have the large number of data. Small number of data. So whenever we take in the large number of samples is value n is higher number of samples, then and estimating the value of lambda, it will be a most probably approximate value. We will get the some approximate value. Here in method of moments, we studied mean of the sample. Mean of this sample is equal to S bar is equal to sigma xi divided by n. S bar is equal to sigma xi divided by n. And here it is a mean equal to 1 by lambda. So we are equating this mean 1 by lambda is equal to sigma xi divided by n. We are equating 1 by lambda is equal to sigma xi divided by n, and lambda is equal to n divided by sigma xi. So this we can write it 1 divided by S bar. So lambda is equal to, this is estimating. So we are in method of moments. So we estimated and we got the 1 divided by S bar. This is a method of moments. In last class we studied the method of moments. We estimated and find out the value of lambda. Here we are going to study the likelihood function. So through the likelihood function we are going to estimate. So how to find out the likelihood function? In likelihood function we need to find out the probability density function. So this population is following the exponential distribution. So we know the probability density function. How to write the probability density function? We can write it is a f of xi. Probability density function is f of xi is equal to f of s1 and f of s2. This will be f of s2 and f of s3 and f of s4 and up to f of s5. Each f of hn. Each samples we can write the probability density function PDF. So this we can call the PDF. Probability density function is representing f of si. We need to write the each terms f of si for the each term. So step 1 is saying about the step 1. Step 1 in the maximum likelihood estimation. First we need to find out the likelihood function. So we need to find out the what is the likelihood function. Likelihood function is representing L and unknown parameter is representing theta. This is equal to product of I is equal to 1 to n. In the sample we have to take a 1 to n. So 1 to n we have to take all the values and f of xi in unknown parameter. This is a probability density function. So each probability density function need to multiply. For the likelihood function, finding the likelihood function, each probability density function need to multiply. Here we need to multiply. So what is the probability density function for this case? F of xi is equal to, here it is a exponential distribution. What is the PDF for the exponential distribution? PDF is equal to, we can write the PDF is equal to lambda e raised to minus lambda x. So this is the PDF function for the population is following the exponential distribution. So we know the probability density function is the lambda e raised to minus lambda x. So each case we are going to substitute f of s1. We are going to substitute the lambda e raised to minus lambda s1. Lambda e raised to minus lambda s1. In this one we are substituting lambda e raised to minus lambda s2. So each f of s3 and f of s4, lambda e raised to minus lambda s3, lambda e raised to minus lambda s4, and lambda e raised to minus lambda sn up to sn. So our probability density function for each case, probability density function for each case is lambda e raised to minus lambda s1. This lambda is a unknown parameter. We don't know the value of the lambda. We're going to estimate the lambda value. So s1, s2, s3, s up to sn we have written here. In first step we asked about the log likelihood function. It is a product of f of si theta. So we need to do the multiplication. So this is a product. We need to multiply each terms. So how we'll get here? We are representing, we can represent L of lambda. Here it is a theta. Here we need to represent lambda because we are finding out the value of lambda. So lambda value is equal to product of I is equal to 1 to n f of hi. We can write like that, f of hi comma lambda. So instead of f of hi comma lambda, f of hi, here we can write f of hi comma lambda is a probability density function lambda e raised to minus lambda hi. We can write like that. Now it's a product I 1 to n. How to get this value? We need to multiply each term. Now we are going to multiply each term. We will get the value of lambda, multiply the lambda 1, 2, 3, 4 up to n is there. So lambda raised to n. Lambda raised to n. This is a multiplication symbol. I is 1 to n. So lambda raised to n and e. Here it is e raised to minus lambda s1. So we have to add here. So e raised to minus lambda we can take out. Then we have a s1 plus s2 plus s3 plus up to sn. So we can add this one, we can write sigma hi. We can write it is a sigma hi. So we are multiplying each probability density function for this sample. We got the lambda raised to n minus e raised to minus lambda sigma hi. So this is the first steps, likelihood function, finding out the likelihood function. Second, step 2, log likelihood function. We need to find out what is the log likelihood function. So this is my likelihood function. Log likelihood function L of lambda. How to find the log likelihood function? Log of lambda raised to n e raised to minus lambda sigma hi. Lambda raised to n e raised to minus lambda sigma hi. So this is the log likelihood function. We need to expand this one. So we will get expanding. Here we will get log lambda raised to n. Log lambda raised to n plus log e raised to minus lambda sigma hi. So log is given for both. So it's become plus. It's a multiplication. So it become plus. So this is we got like that. This is ln log of lambda. So log of lambda raised to n. So that we can write like that. N we can take it to here n log lambda. Here log and exponential function we can cancel. So it is become minus lambda sigma hi. So logarithm with the exponential function we can cancel each other. So minus lambda sigma hi. So this is my log function. And third, so we find out the step 3, differentiating the with respect to lambda. Differentiating with respect to lambda. We need to differentiate with respect to lambda. So d divided by d of lambda log L lambda. So this term you are going to differentiate. This term going to differentiate n log lambda. So with respect to lambda. So we will get n multiply with the log lambda is equal to 1 by lambda minus, this is constant. So lambda is constant minus sigma hi. We got the minus sigma hi. Lambda if you are differentiating it is a 1. So minus sigma hi. And step 4, this is equating to 0. Step 4 is equating to the 0. So we are equating to the 0. So what will be equating to the 0? What will be the value? N divided by lambda is equal to sigma hi. So we equating to 0. So step 4, n divided by lambda equal to sigma hi. Sigma hi is taken to this side. Next right side. Minus sigma hi is become plus sigma hi. So lambda is equal to, lambda we can take there, lambda is equal to n divided by sigma hi. N divided by sigma hi. So this is the estimated value. We put the cap. This is estimated from the sample. We need to put a cap. So we got the lambda is equal to n divided by sigma hi. This is estimated value. It is not a absolute correct value. So this is approximate value or estimated value from the equation. So estimation is representing cap in top. So lambda raised to lambda is equal to n divided by sigma hi. So this is same. This is same. We initially we find out, this one is through the method of estimation. We find out lambda is equal to 1 divided by s bar. So same, lambda is equal to n divided by s bar. So this is same as like that. So in the maximal likelihood estimation, first you need to find out the likelihood function and whether it is a maximum or not. You need to find out whether it is a maximum. So through the log likelihood and differentiated, and we have a step 5 to maximum or not. We have to check it step 5 whether it is a maximum. We have to check it whether it is maximum or not. So this is estimated value, whether lambda will be maximum or not. How to check? This is a d square divided by d lambda square ln l lambda is equal to, we have to differentiate again. Differentiating again, 1 divided by lambda n into 1 by lambda is equal to minus 1 divided by lambda square. This term is equal to minus 0. So this we can write minus 0, and this we can write like that, n divided minus n divided by lambda square. So this is equal to, this is negative. Negative means it is a maximum. Negative means it is a maximum. So we have checked whether it is a maximum or not. What is the find out the value whether it is a maximum or not? I am checking second differentiation. Second differentiation is become negative means it is a, what we find out the value lambda, it is maximum. So we have 5 steps. So maximum likelihood function, first you find out the likelihood, then estimating the value, then whether it is a maximum or not, checking the maximum. So step 1 is a population. Population is following the exponential distribution or normal distribution or Poisson distribution, whatever distribution. We need to find out the parameter value. We don't know this parameter value, need to find out the parameter value. So for that we have taken some sample. Sample is taken S1 to up to Sn, and probability density function, we find out the probability density function for the each sample. S2, S3, S4, like that each sample. And first we the log, step 1 log likelihood function. It is a product of the PDF, probability density function. So it is a product of the PDF. We multiplied with each probability density function. We got the lambda is equal to lambda is n, and this one we have to add e raised to minus lambda sigma. Step 2 we have find out the log likelihood function. So log likelihood function we got like that. Log is given to both term. Third, we are differentiating the log function. So differentiated log likelihood function. So it is a lambda with differentiating with respect to lambda. So lambda is differentiated here. Lambda is minus 1 sigma hi is a log lambda is 1 by lambda, equating to the 0. So we are equating to this term is equating to the 0. Why this is equating to 0? By estimating the value. So it equating 0, n divided by lambda is equal to sigma hi. Lambda is equal to n divided by sigma hi. And we are checking. Now we estimated lambda value. Once we estimated, we have to put the cap lambda is equal to 1 n divided by sigma hi. And next we are checking whether it is maximum or not. Second differentiation, again differentiated this term. So it is a 1 by lambda is minus 1 by lambda square. So minus n divided by lambda square, it is negative. This term is negative, so it is a maximum value. We can check some example. Exponential distribution. Population is exponential distribution. We are checking the lifetime of bulb. Lifetime of some bulb, light bulb. So checking the lifetime of light bulb is following the exponential distribution. We know the what is the lambda value. So number of bulbs are there in the population, large number of bulbs. So some particular company, you have to say some particular company, large number of bulbs are there. You taking some sample of bulb, whether there what is their lifetime. So sample is taking the 5 samples. So we taken the 5 samples. So n is equal to 5. 5 bulb is taken from the population. Population means a large number of bulbs are there. From the bulbs we taken the 5 samples. So first life, first bulb 2 years is worked, and second is 3 years is worked, third is only 1 year, and fourth bulb is worked 3 years, and fifth bulb is worked 4 years. So our sample is taken. First bulb is worked lifetime, we got it 2 years. Second bulb is 3 years of lifetime, and this one is 1 year, 3 years, 4 years. So your sample is only 5 bulb. Taking the 5 bulb. So here we need to find out the PDF function. So lambda raised to here s1 is the 2. So we have a s1 is equal to 2, and s2 is equal to 3, and s3 is equal to 1, s4 is equal to 3, and s5 is equal to 4. So we got the PDF function. Now we are writing the likelihood function. So likelihood function is lambda e raised to minus sigma xi. So here I is equal to 1 to n is equal to up to 5 only. I is equal to 1 to n, we have only 5 samples. So we written, so n we got the 5, and sigma xi we have to add it. Minus 2 lambda plus minus 3 lambda plus minus 1 lambda, we are adding, we will get the sigma xi is the 13. So we can write as a 13 minus 13 lambda. We can write it minus 13 lambda. So first step we written, we multiplied, and we got the lambda raised to 5 e raised to minus 13 lambda. Second step, log likelihood function. We return the log likelihood function. So what we will get? Log likelihood function, it is a 5 and it is a 13. So here we are changing to, here is a 5 and here it is a 13. So log likelihood function, 5 log lambda and minus 13 lambda, we written like that, minus 13 lambda. And now differentiating, third step is differentiating, going to differentiate. So we get the, this is a 5 and this is a 13. So it differentiated, n divided by 1 by lambda, and here it is a lambda is differentiated, we got the 13, and now we are going to equating to 0. So this is equating to 0, so 5 divided by lambda is equating to the 0, so this is a 13. So estimated value of lambda is equal to, estimated value of lambda is taking that side, so n is equal to 5 divided by sigma xi is equal to 13. N is equal to 5 divided by sigma xi is equal to 13. So this is estimated value of lambda, 5 divided by 13. So we got the lambda value, lambda is equal to 5 divided by 13. So estimation lambda, whether it is a maximum or not, that is already checked. It is a minus only, it is maximum. So that is the example for the maximal likelihood estimation. Now we consider population is the exponential distribution. The same way we can find out the population Poisson distribution. What will be here? It is a, whether it is a Poisson distribution. So in Poisson distribution also it's mu. We are representing mu. Poisson distribution is representing mu. So now this population is following the Poisson distribution. So we have a mu, value is a mu. So this mu, we have no idea what is the value of mu. This population only following the Poisson distribution. So mean also is actually mu only. So we have a sample. We're going to take some sample. So n sample is taking from this population. So we have a s1, s2, s3, s4 and s5 up to sn. N sample is taken from the population. So now we are discussing the Poisson distribution. F of xi. What is the PDF of the Poisson distribution? PDF is equal to lambda raised to xi and e raised to minus lambda divided by s factorial. So this is the PDF of the Poisson distribution. We can write PDF is equal to lambda raised to xi e raised to minus lambda divided by s factorial. So this is the PDF. So PDF is written here. So PDF function, we need to write the PDF function for the each case. So each case we need to write the PDF function. So for x1 we have a lambda raised to x1 and e raised to minus lambda divided by s1 factorial. And second is lambda raised to s2 e raised to minus lambda divided by s2 factorial. Lambda raised to s3 e raised to minus lambda divided by s3 factorial is up to lambda raised to sn e raised to minus lambda divided by sn factorial. Up to we find out the PDF function. PDF function we written the lambda raised to s1 e raised to minus lambda each term we find out the what is the PDF function. Next, now after this PDF function we finding out the what is the step 1. Now we can easy to identify, you can write it is a log likelihood function I is equal to 1 n f of xi. This is f of xi. So f of xi is available here. Now we are writing the equal to n. This is instead of here it is a lambda raised to xi e raised to minus lambda divided by s factorial. So we written the I is 1 to n lambda raised to xi e raised to minus lambda divided by s factorial. So what will be the value? What is the value? We are multiplying which each term going to multiply here. Each FSI is multiplying here. What we will get? We can directly write from here lambda raised to xi. So lambda raised to xi x1 plus s2 plus s3 plus. So we can write it is a sigma xi. Lambda raised to xi you can write a sigma xi. Not a lambda, it is a mu actually. In Poisson distribution we are writing in mu, so we can change instead of lambda we can take the mu. We are taking the mu. So here it is a log likelihood function. This we can take as a mu. Log likelihood function is taken mu. So it is a mu xi e raised to minus mu. So this is we are taking the mu. So this is the PDF function. We taken the L of mu is equal to mu raised to xi e raised to minus mu divided by s factorial. So if we are multiplying, what will be the value? Which we are multiplying, we will get the mu raised to sigma xi. This is 1 s1 plus s2 plus s3 mu raised to sigma xi, and e raised to n mu minus n mu, e raised to minus n mu. This e raised to minus mu, here it is a mu only. Here we are instead of lambda we have calculating here mu only. So e raised to minus mu multiply with e raised to minus mu and e raised to minus mu. So it is a e raised to minus n mu, and down it is a s factorial. It is a constant, we don't need to consider the constant mu because there is no mu terms in constant. So log likelihood function. So log likelihood function in terms of mu. Here next step substitutes log likelihood function. Log likelihood function is mu raised to sigma xi. So log of mu raised to sigma xi e raised to minus n mu, and we can write all divided by that we can write as a constant plus constant. We can write a constant. Some constant is there. So this is the value log mu raised to sigma xi and e raised to minus n mu, and constant will be there, written the constant. And log likelihood function we can change it. How to change it? Log of mu xi, that we can write mu xi log of mu xi log of mu plus log of e raised to minus n mu plus constant is there. Constant is after differentiation, this constant will become 0. No need to consider this one. So log of mu plus log of this term is become log and exponential function. So it is become minus n mu. Minus n mu. So now we find out the log likelihood function of mu. Find out the log likelihood function of mu. So sigma xi log mu minus n mu. And what is the value of this value? Is become mu. Step 3, differentiating with respect to mu. Differentiating with respect to mu. So we are differentiating, going to differentiate with respect to mu. So here it is a mu. So sigma xi log mu. So sigma xi log mu is equal to 1 divided by mu minus n mu. That you will get the n. You get the n. Now you see step 4, differentiating sigma xi log mu. We taken the 1 by mu minus n. Mu is equal to 1, so minus n. And now this is equating to the 0. Equating this term in step 4. This is equating to the 0. So what will get? Sigma xi divided by mu is equal to n. Sigma xi divided by mu is equal to n. So mu is equal to sigma xi divided by n. So mu is cap is required. Mu is estimated value. We got the estimated value. Mu is equal to sigma xi divided by n. This is same as, so mu is equal to sigma xi divided by n. So this is the estimated value. So putting the cap. So this is equal to the S bar. Sigma xi by n. This is equal to the S bar. If you are finding out the S bar, it will be a sigma xi divided by n. So we got the mu. We estimated mu value is equal to sigma xi divided by n. And whether it is a maximum or not, we have to find out whether it is maximum or not. So we have to differentiate again. This is the fifth maximum value. We need to find out the, in case of mu, differentiating again with respect to mu. With respect to mu, we are differentiating again. Sigma xi 1 by mu. Sigma xi 1 by mu is 1 by mu square. And n is become 0. So this we can write minus of sigma xi minus of sigma xi divided by mu square. So this is negative. So this, what we find out the value is a maximum value. So it is a maximum likelihood estimation. Poisson distribution mu estimated is a S bar. It is equal to the S bar. So that is the maximum likelihood estimation. So now we discuss about the only single parameter mu. And next class we can discuss the two parameters. Next class we can discuss the two parameters and incomplete sample size, incomplete samples and independent samples. Some incomplete samples are there. So that we can discuss in next class. Hope you understood how to find out the maximum likelihood estimation. We have a 5 steps. Step 1, likelihood function. We can write the likelihood function. No need to multiply here and all. We can write a log of the likelihood function. Directly we will get this value. That is log likelihood function. And then step 2 is a log of likelihood function. We got the log of likelihood function. And differentiate again. Differentiating the log likelihood function. Then equating to the 0. This is equating to the 0. And the 5th step is maximizing, whether it is checking whether it is a maximum or not. So we got the estimated value is maximum. This negative means this estimated value is a maximum. That is what is the meaning? Maximum means it's the most likely. Mu will be sigma xi divided by n. That means it's the most likely. So most likely mu will be mu is equal to sigma xi divided by n only. So in the population, most likely mu will be sigma xi divided by n. That is the likelihood, maximum likelihood estimation. Hope you understood about this, how to calculate the maximum likelihood estimation. Thank you.